Hello, good afternoon, everybody. I am back with the rear-mounted Centauri Carbon, and I'm here to provide good news for today. I intend on releasing the rear-mounted Centauri Carbon, hopefully, after this video comes out. As you can see here, I have made my own custom riser after using another riser as a remix, and then going in, making my own from scratch. I even added in the Elegoo logo with the Centauri Carbon logo right there, just for the fun of it, just to make it match a little bit more. Here's a quick, slow pan around to everything that I've done so far. So I took a ton of suggestions and I made a ton of work since then and have made a ton of progress. Everything is functioning as intended at this point. And I have had no issues since I made my changes over almost 100 hours ago of print time from now, because I have put a lot of time into this so far. I've got 454 hours, and when I was at my halfway point, I was just barely breaking 400 hours. And not too long ago, I was at 200 hours on this Centauri Carbon. I haven't used it probably nearly as much as some of you have, but I've used it a lot more now than I have in the last year to year and a half when the Centauri Carbon originally came out and I got it in the second wave. As you can see here, this is the work that I have done. People were wanting as one thing to fix. They specifically wanted this vent open and available. So I made it an option. So if you wanted to have it mounted on the right and you don't really care about this very much, I have made a way to access it so you can set it right here, or you can have it on this raised portion that sits further over to the right than this sits over to the left. And it allows you to have the vented system. I'll drop the Printables file for this model. It's meant to have an elbow tube that you hook up, and then you can have it go up and around using, I believe it's 6-inch venting systems. And if this doesn't work out very well for you, there are plenty of other adapters that you could probably make for this model in particular to fit your needs. But this allows this to mount properly, which gives you a lot more options than instead of compared to being in front. And here is the new siphon. Well, I don't know exactly what to call this piece, but this piece right here allows you to pull from 1, 2, 3, and 4, and send all of these in through here, out and over into the bottom of the canvas, and then up through here and into this side. Now you're probably wondering why I don't have the fourth one hooked up. I have done testing on all 4, but after many prototypes and almost 9 kilograms of filament later, I used up all my PTFE tubes from Amazon. And I was really just going to decide I would wait until I received the Capricorn tubing that I purchased. And until today, funnily enough, I had not heard anything from Capricorn despite my order being supposed to arrive on the 5th or 6th. They finally reached out by the 10th and said that it's on its way. So I just decided, while I was waiting for that, I ultimately bit the bullet and just bought some more tubing from Amazon. This is 5 meters worth, and it comes with a filament cutter. Honestly, for $15, it's hard to ignore. It's been doing fine for me, but you'll notice I've got gray tubing here, and then I've got my light gray or white tubing here. And you might be wondering why there's a difference. It's because this is the tubing originally meant to go from here to the inside when you have the canvas set up normally. Instead of use it the other way around, because I figured why not use that and fill out all of it with what they recommended. Plus, you know, I didn't have any that were fitting the right size, so that was my choice. You'll also notice one thing that's a little unusual, and I will share. Normally it goes 1, 2, 3, 4. But in order to achieve a sideways mounting solution, you have to swap 4 and 2 on this in order for it to pull correctly, because as it rotates, it goes and pulls through. But if you ever pull the filament back, it needs to be able to pull back and tighten. And that's what it does. So it would rotate the wrong direction if 2 was here and if the 4 one was here. So technically, still inside the canvas, this is labeled 1, 2, 3, 4. But I'm just ignoring the numbers here. They don't matter anything. They don't mean anything to me. You just set up a filament there, and that's what it matches. It doesn't change anything hardware or software-wise. So this feeds through here, goes through there, into the canvas, and up through here. And ultimately, maybe it's just a little bit more distance, but ultimately, it's not that much. It's not enough to raise concerns, at least for me, when I've been printing. I've been printing for the last 200 hours on this method. Well, not 200 on specifically this layout, but I've done over 60 hours on this final design. And I've become very confident with it as I've been printing pretty much 24/7 for days, that it's going to work well. Here's some of my other modifications, which is why I really didn't mess with anything on this side. I have this that I custom made myself, including this thing to hold my calipers. So, and then I just put this mount over here so I wouldn't have to throw it away because it used to be over here instead. But that is basically what I've built so far. I figured I would go ahead and show you it working so that you could see how well it works. I'll show you a couple of the quirks and how to put this whole thing together. So I'll tear this all apart, have it all in pieces, and then I'll show you how it works. I figured I would do that. So, but first I wanted to show some other functionality. People mentioned wanting TPU functionality, which I did as well. And ultimately I found out that it is able to route through here correctly into the canvas. But the moment it goes to pull out, it gets to here, and it does fine. But then you try and pull it out by rolling this back, and there's enough tension in it that it was making me concerned that it was either going to stretch too much and lose its consistency and thickness, or that it would snap. I didn't really want to have to deal with that anymore, so I got it out safely and slowly, and then said I'm going to create a bypass like Elegoo did, which is why they probably didn't recommend it anyways. So this is my bypass. Let me grab the TPU out real quick. Okay, grabbing my TPU and the PETG from the closet. This is actually part of the reason why I wanted to figure out a lid solution, because I keep all my filaments on this coat hanger design that I found online. It's a spool holder, and it just sits on your hanger, and it can hold 2 spools at a time, and I didn't want to lose that height, so that's why I put that there. I will quickly show you how to put this on, show you the order of operations for it, and then here's how it will go. I'll tear everything apart. I'll then show you how to put it all together so that you understand how it works, so that when you go to build yours, this is how you know it works. And I will then show you some of the different benches that I made. I've also full-on printed stuff on the build plate for all the different models, but benches are a good way to show how well my printer's working. But just as proof, this is made of TPU. I went ahead and made some TPU spacers because I wanted to reduce the amount of air leaking out the top, because I can't specifically feel it, but I have to imagine that it is a problem. And so the nice squishy TPU is meant to help fill the spaces. And I mean, as you can see, this is my template for a riser. One recommendation, regardless of whether or not you decide you want to mount the hosing in here on the left side or the right side, or I guess you can call it the west side or the east side, I recommend putting some foam on the walls here. I did it on a previous prototype, but I hadn't gone to doing it on this one. As you can see, this is just some foam from a 3D printing box from a friend of mine because I threw my box away before I could grab the foam. But the canvas arrives in foam. So I would use the foam from the canvas and I would use it to hot glue this entire section because my hot glue gun, I just put it on the lowest temperature setting for the hot glue, lathered the plastic in hot glue, and then slapped the foam on. And it just gives it something soft to rest against when it's going against the far edge. Well, the close edge. So if it goes all the way to this side for tuning, it lightly presses against that wall. But by having foam there, it just makes it a little bit softer, reduces any abrasion if there is any, which it probably is mild. But it just reduces that wear. So I would recommend that personally. But you can also mount it on the right side, as I mentioned, on the east side of it, which I considered doing until I had it set up like this, and then I didn't feel like turning it back around. To show you how I did this, the build plate isn't long enough to do this entire print in one. It just isn't. I've tried, there's no way to do it other than split it up in two, so I spliced it, made a dovetail, and then made spots where you can put some M3 screws in with nuts to help hold it in place. And as you can see, it's as sturdy as pretty much any other section would be, which is why I'm happy with it. It's not going to have a lot of stress anyways, and if you really need to, you can still reach in here, pull out your little trash bin or whatever, and continue on your way. And as you can see, the cable for this routes around here, down, and around. It's a little bit closer on this side and doesn't really have as much tension, but this tension is safe. It still has some wiggle room and still is fine, which is why I'm okay with it. Okay, let me go ahead and show you how to mount the TPU. I'll show you how to cut this to the right length to make sure that everything works fine so that you don't have issues with the tubing being too short. And then I will go through the teardown process. I will try my best to either put in the description where the timestamps are for different things that I'm running through. But I will also see if I can do it in editing as well. I can't guarantee that. I'm an engineer. I'm not an editor for videos. This is my first time really making a video. So let me go ahead and get my tripod set up and I will show you how it works. Okay. Hopefully this should be sturdy enough. I'm trying my best. The tripod isn't very stable. It's sitting on a toolbox to get a little bit extra height. But let me go ahead and show you how this works. So we're going to go into the canvas settings real quick on the screen. And we're going to see which one is currently loaded, which you can generally see based on the light on the rear which one is flashing. It looks like number 1 is loaded. But you also can just click on each individual roll on the canvas page and see whether or not it will either have it grayed out for load or unload. And so this one is grayed out. Number 1 is grayed out. So we're going to let it go through the process of unloading this, and then we'll go through the whole process of replacing it with TPU. So we'll let it do that for a moment. It just has to get up to temperature, and then it will push its way around and cut it out like it normally does when you're trying to unload with the canvas. Well, with it normally, without the canvas. So we'll just give that a minute. In the meantime, I can show you what other materials I've worked with. I have worked with PETG carbon fiber specifically from Elegoo, and it has worked out actually really well. I will grab those benchies real quick while we wait from the back. And I will show you them one at a time. So you've seen this one before. This is the multicolor one. As dumb as it looks, yes, it's black, wood grain, and then black. They're actually, I have 2 rolls of black on here when I was doing it, and then brown. So that's why it looks a little weird. I don't know how to do the color painting very well yet, but I'll get there eventually. So as you can see, it's going through the cutting process. Here's the TPU 95/8 that I've been working with. and it's very malleable. And then here's PETG carbon fiber. As you can see, it's in good shape. And then the rest of these are just a ton of black benchies that I've done after testing different bits of hardware. So nothing too exciting for those ones. But I also have successfully printed in ASA. I didn't use Elegoo ASA for this one, I used Polymaker. And for all of these filaments, I have been using specifically a ruby tip nozzle with all of this, and that's what I've been printing on for well over more than 60% of the lifespan of this 3D printer. So now that it's successfully unloaded, we'll go ahead and carefully roll it out. You'll know it's past the canvas when you hear a click, so we'll just give it a second. There's the click, and now it comes out at pretty much the same resistance that I felt with the canvas. And once you got it out, just pull it off, put that away, and now we'll grab ourselves the TPU and we'll load it like so. So the way I've intentionally designed this is that the TPU always should go on number 1, and we're going to set it like this for a moment while I do the other steps. In order to do this, you have to specifically unplug the canvas. So I like to unplug it from the actual canvas instead of the rear port because it's a little easier to plug back in. So you unplug the canvas and then tuck the cable away for a little bit. You will then immediately get a notification on the screen that lets you know that the canvas control board has been disconnected, which is okay. This is how they tell you to do it on the canvas for the Centauri Carbon 1. And all we're going to do is behind here, I'll see if I can move you closer to show. Allow me to move you real quick. Okay, let me move into place. So all I'm doing is grabbing just a basic hex bit, just like the Allen wrenches that you would see on the printer. And I press in on the little tool there. But you know what, I'll use an Allen wrench to prove that it can be done. You just press in with it, press forward, and it comes out. That's the only way those will come out. I'm then going to force the feed through here into the canvas, well, into the inside of the carbon, and then on the inside of the model, I'll show you later. Let me go ahead and readjust the screen so that you can see. So all I did is I fed specifically the tubing through the hole and into the inside of the riser. So now it's inside here instead. And all I'm going to do is grab this tube and feed it through this side TPU bypass. And I'll probably redesign the bypass at some point, although with how the mounting is, it's very easy to see in the STL files how you can make your own if you wanted to make it more aggressive or more mild or whatever, or if you wanted to fix the angle. But as you can see, I have managed to feed the tubing from route 1 basically over to the other side, and it works just fine like this. Once you've done that, I'm now going to grab this right here, my TPU. I'm going to roll it around, and then just to save on time, I'm going to turn on the load setting that you would normally get without the canvas, and I'm just going to start feeding it through a little bit at a time, and the temperature should rise up as I do this. The tubing is now reaching the intersection. And it's currently at 150 degrees Celsius, so we'll just give it a second. 175. And so all you have to do is just literally feed it into here, and it takes a little bit of convincing to push it through. You'll feel it kind of pop in, and part of that is because the flat end from cutting off the TPU, regardless of the intersection, the canvas would even have to do this. It has to push pretty hard to get it through the intersection, even though it's about as perfect as they could have gotten it. Trust me, I tried to make my own intersection. It's a pain. But once it gets up to temp, I push it through, and I just keep going. And then it won't look like it for a second, but if I let go now, it's not pulling back. Now you can see it. It very slowly is moving. It's very hard to see. It's very slow on camera. But just to prove the point, I'll click retry again, and I'll place my finger here to show you. See? And now it's fed in. That's all it takes. So I'll provide the dimensions for all this, like the spacing between the M3 screws, so that you can redesign your own if you want to for routing, because trying to route tubes on Fusion 360 has been kind of annoying. So if you want to do something else, I don't blame you. I will provide those details if you're interested. But now it is ready to go for printing with TPU. That's it. That's all it takes. To undo it, all you do is just go into the unload screen. Let it do its whole unloading thing where it cuts the filament. So it's just doing that real quick. And then it will start unloading by pulling the motor back. You can see it going back. And then I'm just going to give it some assistance. Pull it back through. And there. Just like that. That is all it takes, gentlemen and ladies and folks of all ages. And that TPU benchy that I did was done with this method, and so were these TPU top portions that I made. It was also done with this method. So that is all it takes. I'm going to go ahead and I'll do the reverse process. We're going to put the PETG-CF in. So I'm just going to slide it in like that. We'll then come back over here and plug in the canvas. Once it's plugged in, it takes a second for it to boot up. And after it's done booting up, you will then see an entire screen come on specifically on the screen of the Centauri Carbon telling you, just so you know, we've noticed a canvas is connected. Click confirm. And then the same push tab that is on the canvas, they give you 3 spares. I use one of them specifically for this portion right here, just to make sure that the tubing doesn't move when it's not supposed to. And you just want to press in and then pull out, because it is just friction fit, so it can and will come out if you try and pull it. I'm then going to feed it through the guides that I've made, and it will now come out the back like so. And then all I do is feed it into number 1. And there we go. That is all it takes. And it just feeds through here. And there are numbers on here correlated to each one of the routes here, letting you know where each one of them goes. So that, you know, the 1 goes to here, 2 goes there, and so on. And I'm going to take these off for a second so I can show you. Maybe it is easy enough to see on camera, but I'll show you. Do you see the E right there for east, southeast, south, and then there's my username, and then the rest of them all have their own cardinal direction applied to them as a letter. I figured that this was probably the best way with multiple languages to be able to access this and understand how it's supposed to go together. because compass directions have been around for a very long time in human society. So I figured that was my best method. With that said, that is how they all go together, and each corner in each face is slightly unique because they're only meant to go on one way. So if you tried to put the southeast where the northwest goes, it will not work. Same goes for any of the other spots. It looks like it can, but it's off by a matter of millimeters, and it's intentional that way so that it only can go on in one orientation. So do keep that in mind. Let's see here. I'll go ahead and show the loading up of PETG, just so that you can see what kind of thing I would have to do. I'm going to lower this a little bit. Okay. We will now grab our PETG-CF, and you just feed it through this tube right here. And keep in mind, depending on how you cut the tip of your filament, it will determine how easily it goes through the canvas. A flat tip is always a little challenging on the canvas, but as you can see, that required very little force to get it in, and it's the same for all of these. So that's how that works. All right. With that said, I'm going to quickly pause the video, but it will be instantaneous for you. I'm going to disassemble this completely, and then I'll assemble it with you so that you can see how it all works. All right, we're back. I will go ahead and demonstrate. I'll even take off all the riser pieces. I made the tolerances tight enough that you can actually grab it in one piece rather than 8, just by pressing it a little bit. So it's a little tight when it goes in, but it means less rattling. So I'll take it. I'm just going to go ahead and sit back here, and I'll give instruction. I'll double check, and I'll put it in the description. I believe these are 10mm M3 screws, and these ones are 12. For anything really going into the canvas, there's no limit to how long they can be because it just goes in. There's no dead end to it, I guess, if that's the way to put it. And then for the canvas itself, if you look here specifically, you'll notice that I'm using the screws that come with the canvas on all these spots. Basically, go through the entire process of setting up your Elegoo canvas, which is basically just setting this up, doing that, and then doing everything on the hot end, including putting I'm going to call it the junction, putting the junction on right here. But don't put your tubing in yet. Do not put the tubing into the junction yet at all. That should be the last thing you do on your entire setup, because once you put it in, the only way to get it out, to refit it or put a longer piece of tubing in, is to completely tear apart the junction, which is held in by tons of plastic clips. And mine broke mid-testing because I was pushing it over its limit and managed to break it, but I managed to also get it back in place without messing anything up. I will show you how to tear it apart, but it is not recommended. So do not literally have that be the last thing you do, otherwise it will be a pain in the butt to get it fixed. Regardless, so here's the balcony. The way I attach the balcony to the canvas is I grabbed the longest 20mm M3 screws that come with the set that I will put on as an Amazon link in the description. I inserted them through the bottom and then put nuts in the little divots right here where the screws are supposed to rest, because it allows you to keep sending them upwards. So you can just set a nut there, screw it in, and it holds it in place. So the fit's pretty tight, and it works really well for me. It's the best way to hold it in without trying to basically go from the top down, which, I mean, technically is possible. You could do it the other way around if you really wanted to. It's achievable in either direction. Let's just say that. It's achievable in either direction, but you have to remove this first, screw this part in, and then screw that in if you want to do the nuts that direction. But it is there. I wanted to make it easier to take apart without taking apart the balcony. That was the entire idea. But it works both ways. So you just basically are doing the same method you do here, where you grab an M3 screw, and then you have a nut, and you tighten them together against each other and makes them super nice and sturdy. So we'll start with these first. This is using the four 10 millimeter long M3 screws. And my best method to handling these is I do one side at a time. So I'm going to put the top right one in first. And then with my spare hand, I'm going to grab another screw, set it at the top around here, and hold this side. And I didn't screw the other one in all the way, as you can see, because otherwise it wouldn't be flailing around. But now, I've gotten two in. At the very least, for this point in time, it's not going anywhere. So I'm going to grab another M10 screw. Well, an M3 screw that is 10 millimeters long. Insert it on this side. And do the same thing on the other side. And this print is in 3 pieces rather than 1. It uses dovetails. I don't know if you could see that at any point in the video, but you'll see in the file that there's dovetails. All you do is just press them into each other. And because these are screwed in, this centerpiece is not going anywhere. This is not even screwed into anything. It literally is held into place by the 2 dovetails that press it against the wall of the printer. So it relieves the idea of needing more screws to hold everything in place, because it's held in by friction, and then any weight going down here presses in on the wall. So I've basically, all this wiggle room is simply from the dovetails. But because it's printed vertically, it's not going to shear off. It's going to bend before it shears, and it's going to be a lot stronger than normal. Now we're going to do this. I'm saving the hassle of trying to show having to reattach this together, because, I mean, it takes forever. But all you do is just grab an Allen key. So I just grab an Allen key like this, put a nut on the other side, and I just rotate it forever. And eventually, once you got it on, and this dovetail just helps to align it up properly, it's not going anywhere. But I've already got, it should be a 20 millimeter M3 in this one. I did a 20 on it because it's a really long piece, and even then with the 20 millimeter one, unless I widen this hole, which I can't, the only way to tighten this one is with an Allen key. So you can see it jutting out the other side. It does not have very much length, but I like to line it up a little bit and then get some rotations in it using the Allen key. And I built a divot in it to specifically fit with the divot, well, with the bump that the canvas spool mounts create, which provides several points of contact before the side is ever screwed in. So we'll put that in real quick. And this one you can get mostly tight because this area already has a lot of movement on its own, which is why it's not the only place of contact, because as you can see, even with it mostly screwed in, it still moves around a lot. So now I'm going to grab my Allen key or my screwdriver that has that Allen keys on it, and I'm going to go to this side, and I'm going to start screwing into the mounts here. And I'm just going to do it until it feels good. It doesn't have to be super tight because it's somewhat structural, but it's also not that huge of a deal. Because I could probably get away with literally just doing one of these M3s, but I wanted to make sure that it fits the way I want it to. And I'm going to pull down on it a tiny bit because it was bowing just a tiny bit. But once this is in, then it will be nice and straight. Just go a little bit more. And there we go. I intentionally did deep screws because I wanted to make sure it was structurally sound. So as you can see, the only movement is pretty much right here, and that's just because of the length of it and the fact that it's hollow. There we go. Bob's your uncle. I'll set this right here, and we'll grab the riser pieces. Well, actually first, we'll plug in our canvas, which you just go like so. That will start turning on, and now I'll show you tube routing. So all you have to do is just feed it through the holes. So I'm going to go through number 1 first. And there'll be a tiny bit of resistance for me specifically because I am printing in 0.24. This is all done in draft mode instead of any of the others. And then you just push it in after you give it some wiggle room. You want to make sure this goes in nice and deep, so you give yourself a little bit of extra room to work with, and then afterwards you pull back to make it tight because you want this as straight as possible for it to go in, otherwise the canvas struggles a little bit. So I'll feed number 2 through now. Here's number 2. That one's in. Number 3 next. They're right here. This one's a little bit rough, but once you get it through, it's fine. We're going to feed it through the other side. It's rough on 0.24 because this is a prototype behind you guys. So I have the problem of there is an actual gap down here where you can visibly see the housing going through. And I just have to put my thumb there and guide it through the hole still. It will not be the same way for you guys. You have a complete version that doesn't have these quirks. I just didn't feel like reprinting it again for the 20th time. I couldn't even tell you how many times I've reprinted this thing. So just give me a moment. After using 8 kilograms and almost $300 of materials later, I don't want to reprint it again. But it is fixed. It literally was just a minor inconvenience that has now been taken care of. Number 4. Okay, that one through as well. And there we are. 1, 2, 3, and 4. And you just basically want those as straight as possible. And then that is pretty much set. So the actual hardware of it is done. Now I'll show you how to do the rest. Now you probably will set up the balcony and individual pieces on top as you go. I'll go ahead and raise the height again. Let's see. Okay. And ultimately, I've tried it in many different configurations, and I have not found a configuration yet where having them go through certain holes causes issues. So I just run them through whatever one I want, basically. But before I do that, I'll show you how to correctly cut things to length. So all I'm going to do is essentially this. So currently the printer is right here. I'm going to then go inside and tell it that the multi-board and the canvas is connected. And then I'm going to go to prepare, and I'm turning off the motor. Now that the motors are off, because I'm feeding it through this side, I want to go to the farthest corner, which is this side. If you're working with this corner instead, then you want to go to this side. So I'm going to go ahead and pull it forward, nice and carefully, and then as far over to the edge as possible. So now you can see it's literally at the farthest corner. And now all I'm going to do is grab all my extra tubing that I have right here. And once I press this in, there's no going back. So keep that in mind. There is, unless you want to tear apart this, there's no going back. So I'm pushing it in. Now it's in. That will never come back out unless I tear it apart, which for demonstration I might show you in a little bit, because eventually I'll have to do this with Capricorn tubing when it finally decides to show up. Sorry, I've got a lot of extra tubing on the ground. So we're going to feed this absurdly high amount of tubing through number 4, just because. We'll get that started. Now I'm just going to pull it all through. I'll even just grab the extra and toss it in here. It's 5 meters of it. I haven't cut any of this yet. I could have done that to save myself some headache, but I'll do this instead. Okay. And there we go. I like to give it some room to breathe, so and then so you don't want to like extremely tight like that. I mean, you can, but you can give it some breathing space so that it better works for carbon-based filaments. And now I want to line it up with number 4 and specifically give extra wiggle room. So I'm going to go here, and I can see that it probably will be fine right about here. I'm giving it extra wiggle room because it is much easier to make it shorter afterwards than it is to increase the length of the tube. So give yourself some extra room to work with. And if it ends up feeling like it's too long, then shorten it later. But I'm now going to combine it on the clip here. And do the other stuff real quick. Let's see. I'm going to toss it over there. And I'm going to try something. I'm intentionally trying to see if I can get these to rotate a little bit, because rotating them makes them work kind of like a braid a little bit, which can sometimes make them not want to dangle around so much. But I feed them through here. Let's see, just got to get the extra connection going. So number 3, number 2, and number 1. And yes, I did give myself a ton of extra wiggle room, as you can see for number 4. So I'll probably pull that out, to be honest, and shorten it just a little bit, just so that they match all the rest of the tubing. But I've intentionally done it tighter in an attempt to make it shorter, but also to see how it stresses it for you guys. So I'll go like this. The goal is to get somewhat even lengths across all of them. I'm just going to remove like 1.5 inches. And there we are. Now if I push it all the way to the corner, it's a lot happier with me. But there you go. That is all now put together. And it's all functioning. The only issue that I really have left with this, that maybe I'll fix in the future, well, I'll fix right now for you guys, but I'll fix in the future for myself, is specifically with printing benchies and sometimes other fast prints. As you can see, this sits pretty close to the top of the glass. And it only gets closer as it's moving back and forth really fast, and it lightly taps against the glass as it swings. Maybe you can add weights on it and maybe lower it down so that it doesn't swing so much or something or whatever. But I figured in the meantime, this is the base height I'm going to have. But then I'll include ones that are 5 millimeters taller, 10 millimeters taller, 15, 20. I'll provide several different height ranges, and you guys can choose what you want to do. I imagine I tried raising this by 5 millimeters by using the TPU here on the glass, and it wasn't quite enough. So 10 to 15 probably will completely remove the issue, at least for me, and it probably varies from person to person. So I would keep that in mind. It depends on how tight your tubing is and what kind of tubing you do. But I'm just using cheap $15 tubing off of Amazon until I get my other tubing, specifically from Capricorn. But until then, I want to talk about some stuff on the pricing and the file itself. So let me just stand you up right here real quick, and we'll just talk for a minute. From guy to guy, person to person, so I can seal this up forever. All right, you're kind of looking down on me, which makes it feel kind of demeaning. All right, that feels better at the very least. All right, so I intend on listing this file, that file, all of the balcony, except for the vent thing. That's not mine. It's not mine to credit. But I intend on all of the stuff that I designed, including the riser, which is a brand new riser. It's not based off of the one that I was using as a remix. I have redesigned this from hand. I could show you the timelines on Fusion if it really came down to it. But I designed all of them by hand. After spending what could be equivalent to about 3 weeks of full-time work on this, because I'm unemployed, and almost $300 in materials now, which is probably like 280 euros at this point. I've bought a lot of things for testing. I've went up through 8 kilograms of material in testing all this to make sure it works the way I want it to. Because I didn't want to submit something online to you guys before I had confirmed for myself that it works. And so that's why I put nearly 200 printing hours, $300, and 3 weeks of work into this whole thing. And that's why I will be charging a grand total of $5 for this. This ASA is so old. I'd have to check and see, but I printed something out of this ASA. It would have been, I originally got it almost 2.5 years ago because I made snail bait with it. Well, snail bait trapper with it. And so it just snaps every now and again, but it has yet to snap on me while actually printing anything. Only when I am a little rude to it. It's very dry where my climate is. So any time it snaps is because of me and not because of the printer. But I'm going to put it for $5 for the file. And I hope you all are willing to respect that price because I feel it's a fair amount of money for my work and I can't physically go any lower on Printables. They only allow $5 and up for their paid stuff. And the reason I asked for that money when I did this as kind of a passion project is because it's my first real design in the engineering world and 3D printing world that I'm posting public. After almost 6 years of self-taught CAD experience. And because of that, and because I'm actively a college student going into mechanical engineering, this is my way of making money to pay for tuition. So, by grabbing from a pirated download of this or by buying from a free version of this that someone has modified and claimed as their own despite me not allowing remixes for the first 6 months of this. All you're doing is robbing me from my tuition, which I'm not going to chase you down. I'm not that kind of person. But I'd hope that from human to human that you would respect that. But after 6 months and after I've gone through and refined this more, because the way we'll go is all of these will be in one file for $5. And then anytime I feel like I've made significant changes to this, I'll be coming out with new versions that I release on that file, so you can just go back in and reprint the new version of it after you pay for it. That is the intent, because I want you to pay once and never think about it again, and then all you get is just improvements for the first 6 months while I work on this and try and work on it myself, because as much as 200 hours is good, 200 hours is not 6 months worth of testing. So I plan on using this throughout the next 6 months, just like everybody else will be, and I will continue to make improvements as I find them, need for them, but unless I find more issues, I'm not going to come out with new versions. But once the 6 months are up, I will then allow people to remix this as much as I want, and I'll put the original at $5, and if I occasionally get bored in like the next year and a half and find something that finally broke on me after using it, I'll make a new version that's a little bit sturdier and come up with improvements. So, and it will simply be because I want it fixed for myself, and I'll introduce that to you guys as well. I'll probably even make a better version of this at some point. But that is pretty much everything. Yeah, it's nice to meet you all. My username on Reddit is GingySnap, or Garbear, is what it is originally at, but I appreciate you and all your time and all your patience as I've been working on this. Thank you so much for checking this out. All right, see you.